Hello everybody, this is Yunyue. I'm working with Bassam for the second assignment. And now I'm going to introduce the second part of our work. The second part is like we need to use the KAN algorithm to identify the state of one unknown power system. Because actually we have four states, um, the which is namely the high load during the peak period, the lower load during the night, and shut down one of the generator and disconnect the one of the transmission line. So we need to use the KN to identify which scenario correspond to this power system based on the measurement data. Okay, so let's go deep through this assignment, and I will explain to you step by step. The first step is like we need to read the file from the external. We need to from the external world. So it's like one is called measurement and another one is called analog values. Measurement is used for the learning set, and analog values is used for the testing set. So in order to read these two files, we use some strategy like this. We use the file reader, buffer reader, and we store the data into two different areas because what we need actually is the measured voltage amplitude and voltage angle, but not like the RDFID for this assignment. This is done. This is doing for the data file, and data file is for the measurements one, as you can see here. And also we have another method called read data testing, and this one is reading the file data file 1, which corresponds to the external file analog values, which is testing file. Okay, so in order to read the file, firstly we need to read the information from the Excel, and then we need to store it into the array list. And here you can see the type of the array list is called measurement. And the measurement is the same like what we have done in the first part. So the definition of the measurement is here given. And also you can see here we have another one called array list value list. And in this array list, we only store the data of the measured voltage amplitude and the voltage angle. This will be used further for the calculation. Okay, so this is the first step. After we have done this, we already create the database and we store the information that we need from the external file. Then what we need to do is to implement the KNN algorithm. In order to use the KNN algorithm, firstly we need to implement the k-means clustering to divide the learning set into 4 different clustering. Because we have 4 scenarios, so we think we should have 4 different clustering. And in order to do this, we use the k-means clustering that we have done in the first step. So I will just jump this part, and we'll go through the k-means part. So until here, for the up, this is for the k-means clustering. Okay. Until here. Now you see, for the KN means like we need to find the n nearest point of the measurement point, and we need to count which type is the most appear one within this nearest point. So in order to do this, we create a new array list tab called KN value bin. And the definition for this one is given like here. We have the two variable. One is of type value list that we have previous defined, like a class here. And another one is string type. This one will store the type of the state of the power system, and the value list will store the required measurement information like the voltage amplitude and the voltage angle. Okay, so what we have done here is like to store the corresponding value and the type, because we have for the value that's storing in the clustering 0, we have the type 0, and for the clustering 1, we have the type 1. The same for the clustering 2 and 3. Okay, as you can see here we also have another one is like array list kn value main called test data array. This one stores the information that we will be used for the test set, and for this one we have the type 0 because we need to decide what they actually are. Okay, let's go through the algorithm which we will be used to determine the type of the state of the power system. So we have basically 3 functions in order to implement the KNN algorithm. The first one called similar score. So this one is like we calculate the distance between the testing point and the measurement and the clustering that we have already created by using the k-means clustering method. In this function, we calculate the distance of each test point between each test point and the clustering point, and we score it like from the highest to the lowest. Then this will be used further. So the code is here, and then is for the method kn value sort. For this method, what we have done is like after we calculate, we have the score of the function similar score. What we need to do is like we need to arrange the array in order to have the highest score in the first and the lowest score in the end. Because the idea of Kn is like we choose the most similar point among all the other measurement point. So the idea is like this. We use a loop to insert the data into the accurate position based on the score, like let's say based on the similarity between the testing point and the clustering point. After we have done with the method called kn value sort, what we need to do right now is to count the number of the point, and we need to know which type of the point is mostly appeared among the n nearest point. So this is achieved by the method called getTypeID. So in this method, we use a previous defined method called getTypeID, and also here we have a hash map, and this one is actually for the count. So when we identify one type of the point, we will add the number +1. So it's like here. So then what we need to do is like to count the total number of the type, and to find the maximum number of the paired point near the testing point. And finally, we will return the type of the corresponding type. So this is basically what we have done here. Now let's take a look of what we have. So you can see here we take the point number 2 in the test array. And you can see here, the final result is type 2, which corresponding to the casting 2. So this is works quite well for this part, as you can see here. So thank you very much.